Hello everyone and welcome to webinar by aga-cad. Today I'm going to talk about Revit models and I will be showing how those can be exported to different CNC machines, or the CNC stands for computer numeric controlled machines, or CAD/CAM production lines. And CAD/CAM, it's a computer aided either design or computer aided manufacturing. So let's introduce myself. I'm Andrews. I'm an architect and a BIM application engineer here at aga-cad, and I'm the one who's working and developing those CNC exporters for you guys. Most of you, I believe, already know us, but for those who are new to our webinars, let me explain what we do. So what we do, we mostly talk. We meet, we communicate with all you guys, starting from, I don't know, New Zealand and going up to North America, to Canada and USA. We talk to you in Middle East, we talk to you in Europe, Scandinavia, and so on. And by that, we analyze what you do. We think of a better ideas, of a better workflows. We think how new technologies could be applied to your workflows, as well as we collect the best practices, best workflows, and best ideas. And then we implement all those ideas into our software, into our solutions, into our methodology, and we share all those ideas with you guys. And our main purpose is to automate various processes so we can eliminate all those technical tasks as much as possible, as well as we try to decrease the possibility of human error, because we try to automate and do things so computer can design more and more for you. And all those things just in total can ease all your processes. And this allows you to spend more time on tasks that brings more value. And also this actually eliminates all those tasks that shouldn't be done by you, which can be done by the computer. And actually, we have, I believe, the biggest portfolio of Revit tools. I believe most of you already have at least tried a few of those. And today I'll be showing the models that were created using our wood or metal framing tools. And I'll be just exporting them to different CNC formats. So today I'm actually going to talk mostly about few of the formats or the machine manufacturers that are mostly used by our clients. So I'll just show you those companies and the formats that being read by their machines. Also, I'll show you few examples, what kind of information I have in the model, and then where this information appears in the exported file that you can view, for example, with a viewer. Also, I show you some let's say nice exporters which can do not just a simple cuts and drills, but can create all those complex connections with all the tenons, mortises, and so on. And of course, I will view it not only as text files, but also I have some viewers for those specific formats, as well as I have some CNC machine simulators. And actually, I'll start with the metal exporters. Sorry for those who came just for the wood framing, but I'll try not to take much of your time, and I'll firstly would like to talk about the metal CNC machines, and as those are really simple and comparing to the wood ones, and it won't take much time, I'll just show you the main things for those who are interested more in metal. So actually the metal framing machines are those usually called the roll forming machines, where we have actually a machine. Here is an example from Howick. It's actually the most popular one. You see 4 more companies listed here. Actually, the 5th one is Weinmann. But the Weinmann is more creating the production lines and machines for wood framing. We just have few clients who adjusted their production lines and combined them with some metal roll forming machines to have the whole panel, not just the frame, but together with the sheathing and so on. And we have also solutions for that for the metal frame panel producers. So as you can see, here is a machine created by Howick, and it's a simple machine called a roll forming one. So here we have a roll of a metal sheet that's being just pulled by that machine, and then machine pulls it. It bends it into different profile shapes, C or U profile, and then it makes all the drills and cuts. And here from then the stud just comes, and it can just either taken or it can fall on a rounding table, and then those studs could be used for the production. By the way, I forgot to mention that not only cuts and drills, this machine also marks the elements to know which element where to place. So let's switch to Revit and see how it works in Revit. So here I have a small Revit model, and here which was created recently using our metal framing tool. So what I'm going to do now is to export it into different CNC formats. So I'm taking our CNC metal exporter, and actually as those formats are really similar to each one, there are actually a few different, let's say, formats, but in between all others are similar. And actually I have only one simulator and one viewer for the metal framing. So I'll just try to explain what we have in those formats while viewing them in a notepad. So as you can see here, I don't have now any files exported, so I can export just right now the files that we can check. So besides that, the tool can calculate the screws needed for the production, which I'm not going to talk about today. It can export all your frames into the CNC machine readable files. So first you need to set a default CNC type. So actually if you purchase the tool, we help you to create those configurations based on your machine, based on the tools that your machine have. And as you can see, I have 3 configurations for Howick, 2 for Metroll, 1 for oil, and 1 for ScotSim. So actually, maybe we'll show you 2 most popular Howick formats. It's CSV and CSV2. But I will view them in text editor, then I'll show you those 2. And then I'll show the ScotSim, which has a viewer as well as the simulator. So let's start with the Howick format 1. And we can just select the viewer, click on export frames, take a frame to export. Here's the file was created. As you can see, it's just great right now. It's 11:12 in Lithuania. It's actually 11:13 already. And let's export one more time. Same or different wall with different configurations, which will be CSV2. So actually that one I can view in Excel. And this is the CSV1 format. It's really simple. All you have is just information about the units. Then you have the panel name. And each of the elements is being exported just as a single line. So if you take, for example, the last line, it's a vertical stud. And if you go to our model, you can see that, for example, that element was vertical stud 1. So what the tool actually does, it exports its label, the position where the label should be printed, which you can set in the exporter, as well as the length of the element. So as you can see, the length is 3498, as well as it visible here. And then it just goes and places all those elements like dimples, swatches, and so on. So this element can be connected to that element without any additional tools. And this is how each element is being exported into CSV. And as you can see, it's pretty much simple. Each line is an individual element with its mark, length, and then the comments that should be applied to that element. And if you compare it with the CSV2 file, which is that one, I believe it's the same panel. Yep, so I need to rename it so Excel allows me to open it. Yep, the same panel. So it should get a different name. And to compare those formats, you can see those are very, very similar. Just the biggest difference in the CSV2 format, except of that it says that it's CSV2 format, are those values in between the label and the length of the element. So here we have the information not only about the element, we also have information about the element's position in the frame, where it is. That's why whenever you load this file into Howick machine, you can actually see the whole panel and see where this element should be placed. That's the biggest difference, and the rest is actually the same line with the same commands. Of course, you can change those commands if your machine understands them differently, or if you have a different tools. For example, if instead of a dimple, you're placing slots to have the tolerance for your plates to move, then you can, of course, change those commands. But all in all, it's a simple file with just lines and so on. Let's switch maybe now to a different format, and I'll show just really shortly how those looks like. So if I go to Metroll, I don't know which one you can check, doesn't matter much. And then I need to export that wall frame here. You see 2 files were actually exported, and now why those 2 files, not one, because the plates and studs are, I believe, were created differently. So you see I have one file for plates, another for studs, and if I open up that file, you can see each of the elements in here with needed commands, but I believe that file was actually exported, yeah, with the connections, so get just the length of the stud. But if I export it with that one, it should create for me also the information for the commands. Yeah, so you see, get the name of the mark, you get the name of the element as well as its mark, and then on each, at what length, what kind of command should be applied. Again, different element, positions of the commands, and how those are applied. So as you can see, it's pretty simple. And for example, the format Royal is very similar to the Howick one, and also using a CSV format. So if I just go and export that or any other word to that format, you will be able to see that the plates and studs were also exported separately as the machine needs. And here's pretty much the simple thing that we could see with the Howick export. It's a component, it's a mark, plus it adds the type of the element as well as its also type if it's plate or stud, then where the mark should be printed, and length, and all the commands right here, as well as the, I believe, the position of the element in the panel. And let's switch to the last, maybe least popular format, which machine is created by ScotSim, but it's getting more popular, I believe, right now, because they're like improving it. And actually for that format, I have an export viewer, so we can export maybe more complex wall and see how it looks like in that viewer or simulator. So I switched to the format, and I need just to export that wall right here. And if we check that folder, it was created just right now, 11:18. You can see the time on my watch. And here's the file. So what I can do, I just drag it down, I just place it in here. And as you can see, I get the same view that I've just exported from here. See my 2 windows, my brace group, and it's exactly the same here in the model, actually in the viewer of the ScotSim machine. Then the viewer treats it. It also can adjust the connections and so on, which, because that information is not being held in the CNC file, you just set up it in your machine settings, and then by analyzing those connections, the machine knows should it apply a cut or should it, I don't know, apply a entruss command and so on. Also, we can go and check the same files in our simulator. Of course, it's telling me that I have a machine with me right now, so let's ignore those errors. And let's ignore that one too. So the simulator just started, like this program actually started in simulation mode because, as I said, I don't have the machine with me. But what we can do, we can go and check that file, which should be actually txt. And that's the file that I've just exported. If you open it up, you see that's the name of the panel that, let's say, I'm going to produce. And if I go back to my Revit and select my actually wall, I would see that this is EW for the panel, exactly the one that I've just imported into Scottsdale machine controlling tool. So I'm just moving it for the production. I'm clicking OK, it's ready. And all I need to do is to start the production. But as I mentioned, it's just a simulation, so nothing special. The tool just goes, checks all the elements, tries to produce it. If there are no issues, it just passes it. And as you can see, it just runs, goes. And everything seems fine for now, let's say. So actually, shortly, that would be it about the metal exporters, and the one which is called a Weinmann WUP metal exporter. It's actually the same as the wooden one. So if you're interested how the multi-layer walls could be exported, both metal and floors, just stay with us, and I'll show you that exporter a bit later when I'll be talking about wood exporters. So if you have any actual questions regarding the metal exporters, feel free to ask them in the questions tab so I can later check them and answer for you. And let's now just switch to wood CNC machines or production lines. So here you can see three machine manufacturers, the mostly used by our clients. So it's a Weinmann, Randek, and Hundegger. And as you can see, actually, we have different exporters for each company because they create production lines, they create just a single machines which can do different things. For example, one machine can just cut and drill elements, another like that one, another can, for example, do a more complex cuts for more complex connections, as well as we have some exporters for paneling or sheathing, which can be used then for CLT panels or just regular sheathing like here, as you can see in that image. And also for Randek, we have production line or a simple machine, and for BVX, we have either those complex cutting formats or a new file format which can hold multi-layers, as well as the paneling, because that one can only proceed the single layer of the frame. So let's go back to Revit. And right here I have a model which was kindly shared by my colleague. And this is just a simple wooden house which was created using our tools. I can show you with that view that actually each wall has a lot of layers. So just exploded one wall for you to see that from more layers. You'll actually see that later in the exporter. But let's firstly check the exporters that we have. And let's say that we start with the exporter, which is that one. This is the most simple one, but the Randek also has a production line exporter. Actually, they have just a tool that reads that file, but we created the exporter, so those were created by Randek. Then we can talk about the BTL, we can talk about the Hundegger, then let's talk about the Hundegger paneling, and Weinmann WUP, as well as that paneling exporter right here. So as those the most simple exporters can support just one layer, I'll switch to the main layer framing. This is upside down, so let's just take that house. And for all of those exporters, I actually have a viewers except for that one, because this one is the most simple one. And just to check, let's see how it exports the wall. So what I need to do is just choose what you need to export. So let's say I'm exporting that wall. I'm choosing the configuration by which it should be exported, so I can preset up what kind of values should be taken where and applied where, and what kind of commands for cuts should be used, and so on. So let's see, that file should be created right away. Here you see it was created. Here's my wall, which was W7. As you can see, it was just created right here. And actually each element was created as a single file. And if you open it with a notepad, you will see that here's a mark of the element, how many of those elements you should get, the length of it, as well as the profile. So it's 120 by 45, and then at what degree you should cut the element, and maybe you need to drill a hole, so it will be written in that file. but as you can see, it's really simple. It's one framing element per file, so nothing special, let's say. And if I switch now and export the same or any other wall, let's say maybe let's take that one with 2 windows on the door and export with BTL exporter. Of course, it also has a setup, so we can go and check the set of things, how I'd like to set it up, but that one also can export just one layer. But you can set up, for example, where to print marks, what kind of parameters define your marks. So my setting says that the mark that is going to be printed, it should be created. You see, mark is equal to 2 parameters taken from the project, which is CNC part name and CNC part number. And I'll just show you how those are being exported into BTL. So if I'm exporting, for example, that wall, I'm choosing the configuration by which it should be exported. And if I'll just go back into my folder, one more file should be created. Yes, you see this is the BTL file, and you can see in that viewer that this is exactly the same panel that I've just exported. See 2 windows and the door, the same one that I had in Revit, as well as all those marks were also exported. So I can just, for example, select one element. And as you can see, here's the element. So it was the element above the door. So it's W1 wall, 11, 12. And if I just go back to Revit, actually I need to close that window first. If I select that element, you can see that it took my CNC part name and it added the part number. That's why I'm getting this mark exported into that format, and here it is. And actually this is a simple example because the element just needs to be cut at 2 ends with that command. So if you, for example, okay, I don't know why it doesn't show me those commands. Seems that it's frozen, so maybe let's restart it. Check the same element, and actually if I click on those commands, you can see that those cuts are being done, being made, and here's a lap joint being made here so that top cripple can fit onto my header, and also the marking was applied. So this is just a one layer export for, let's say, mainframe or for additional layer, and each file consists of one layer elements and then all the commands needed for it to be exported. Of course, other exporters can do the same, but let's maybe check them with more complex situations. So for example, the same one, the BTL, can be used for a heavy timber. So if I switch to that project, as you can see, we have different examples of different connections, more complex connections, and so on right here. So maybe let's try to export from here, maybe that truss. And I'm taking the same exporter, just I need to say that I need to export the truss, not the wall this time. So it allows me now to choose the configuration and then to select the truss that I would like to export. And if I wait for a while, the file will be just created right here. Yes, so the file, and this is the same name. And just for you to check that that truss, I believe, is also 101. Yes, it's 1 minus 1, sorry, the truss. And let's open up this file in the viewer. And as you can see, all those things were exported. So if I, for example, select that element, and if I rotate it, you see more commands were created for that more complex element. So not only the cuts were made there, also the drillings were applied, as well as tenons and mortise commands were applied, so this truss can be easily assembled and fixed. Also, they were applied around arch cuts. As you can go to the model and see that there are like families placed on that element using our tools like smart connections or smart details. It was applied. This element has the information which was filled by the tool, as well as some information here. And then you can see that information right in the exported file, and this element's actually ready for production. And you can actually do the same and check the same with a different exporter for a different machine, which was created by a different manufacturer. And let's say just take that exporter, and let's now export just one element, because when we have those more complex cuts and that format is more complex, let's not just waste your time and export one element instead of the whole wall. So I'm selecting the element, and just right now it will be created in this folder as well. In the meanwhile, let's maybe stop that production, exit that viewer, and see what we will get for the BVX. You see even one element taking some time. Yeah, so the element was created. Here's my element, and now I actually can open it up. And here are my parts. Here's my element. And as you can see, that was my top plate with all the connections. So you see those connections for the studs, exactly the same ones that, sorry, I need to close that window again. So you see there were like cuts made here, as well as those elements were connected through here. And then I'm having, see the column connection and two connections for those braces, as well as again. And all those things are detailed with all the commands, what the machine should do, with what kind of values, how deep should it drill, how deep should it mill, all those connection things. So you can attach all the parts easily, and you don't need to manually adjust and drill any other things for that beam, let's say. So you can see just in a few clicks you can export it really quickly, and machine can start and create all needed elements for your panel or the building, because that one actually is not a panel. As you see, it's a whole wall with the posts and beams. As you can see, the exporter, those two exporters can handle all that information really easily. And maybe let's go back now to our pad building, and now let's check two exporters which are designed for production lines. And those exporters can support multi-layers. If I go, for example, to export setup, you can set up how many layers you would like to export. So now I'm exporting all the layers, and let's just really quick check how it looks like. So I just go and click, let's say, on that wall, choose the configuration, click OK, wait for a while until the file is created. It's taking some time, of course. I have, I don't know, 5 layers there, sheathing, main frame, and all the additional like secondary frame, siding, and nailers. Plus the sheathing, it's not framing elements, those were created from parts. I can show you just in a matter of a few seconds. As you can see, the file was created. Just need, let's wait until it's being finished. Yeah, here it is. We've got the notice. Let's open it up. And here is the panel that was exported. And as you can see, I have all the layers exported with the sheathing, all the nailers, frames, and so on. Of course, I can rotate this panel, and I can go and maybe turn off some layers so you can see what is inside. As you can see, everything was exported, so you can see those purple lines which means the cutting, where the tool needs to cut the siding or the sheathing. Those crosses are the nails, I mean. So if I'll just turn it back, you could see that each one nail per siding element. That was because my exporter was set up for that. Of course, you can change it if needed. If you just go to, let's say, advanced setup and say that you don't want to have one nail in the center, you might need to create a different rule with different settings. And the thing here is that you also can filter out some nailers if you don't want, for example, to nail it each element to each of the nailer. You can just filter them out. This is actually what you see, and it's ready for the production line. You pass this file to the production team, and they will know what to do and how to produce the whole panel for you. And the same will apply actually for the WUP exporter. We can take maybe more complex wall like that one. Let's maybe isolate it. And right here we see that wall. And actually, all I need to do, of course, create the configuration, how I'd like to export it, and so on and so forth, but everything is ready. All I need to do now is click and export it. Click Escape, choose the configuration that was created in advance. And just in a matter of a few seconds, the file will be ready with all the information needed for the production. So as you can see, the file is created. It's that one, and I will open it with Weinmann viewer. So as you can see, everything is the same. Just you might get confused that you will think that those elements are exported as rectangles, even though I have them with a slope top, but actually it's a pre-cut. It's a size before the cut. So if I'll just, for example, go and delete one element, you can see that here is the yellow line which defines the cut, how those elements should be cut after those being placed on the panel. As well, that the same thing applies for the sheathing. The panels are being applied and then those being cut by that yellow line. And for example, all this information, if you select any element, you can see it has its mark. So for example, if I just go really quickly to select one element above the window, you see it's VSD10. So if I'll go to my Revit and select that element, oh, it was that one, I believe, you can see that that one was the VSD10 element. And for example, there are different conditions how it need to treat different materials. So for example, this element is a plywood. So Weinmann needs to know that it's a plywood and it needs to have its own index. So index is also taken from the Revit, and you can create your materials with correct indexes before the exporting. So everything is later done automatically, and machine can automatically know which tool to use to cut each layer depending on the material for that layer. So if I'll just go and check that material that was used for the export of the sheathing, I check the parameters and I can see that material index is 90, the same as I can see here whenever I click on any of the sheathing. And if I click on the wooden element, you see it has a different index, and all information how it should be created is already in that file. And as you can see, all the layers with all the service holes, all the cuts are here, and it's ready for the production just in a matter of a few clicks. And if I go and close that, and I can actually really shortly show you the last two exporters, and for that I will switch to our CLT sample project. And actually, it's really, really simple. I'll take, for example, the BVX exporter. There are some settings, and all I need to do is just export, let's say, I don't know, that panel to the exporter. Click OK. Here's the file. Here's which was created. The difference is here that I can't open it up with my BVX exporter because it supports only BVX1 file, and this one is actually BVX version. Actually, this is also one, but that exporter supports only one layer file, and this one needs to be opened with another one. So that's why I'm going to run this Cambium software just to show you how the file looks like there. And maybe in the meanwhile, I'll create a CLT file for any other panel. We can, for example, take maybe that panel with that cut, so you can see how this cut being exported. See, the file was created. The Cambium is already here. What I need to do is to import my file. So here's the file. Here's the tool. And if I'll just go and check that file, edit tool, you can see here's the panel. It was created with that connection cut. And here's the what I saw in Revit. You can see that it was that panel. And now that panel was created for BTL, so I can go open it in BTL. And here's my panel in BTL with the outline cuts as well as all those specific cuts, and even with that mortise command right here, so you can attach those panels later. The same could be visible in that exporter, you see the outline as well as single commands to create the panel on your production line, and it will be ready for the production within those few clicks. So actually, shortly, that would be it for today. Thank you for your time, and if you have any questions, support for technical questions, info for sales or general questions, and our webpage, of course, to see what we do, who are we partners with, and so on. Have a nice day. Stay safe during this time. Bye.
aga-cad, building BIM together.